Hi everyone. We will continue chapter 7, second part. Convection. Convection in which heat is carried by the motion of hot fluid. Convection is the transfer of heat energy by the movement of molecules from one part of a material to another part of material. For example, in a glass or liquid, the molecules can move much easier than in a solid. If you remember, chapter 1, we talked about the three states of matter. Solid, they are not moving, only they will be vibration because of each particle close each other. Convection, for example, if we are looking at this figure, the figure they are giving the three examples of heat transfer. Cool water, it is sink in the container and cools at the surface. Convection, current, and hot water rising. It is showing this figure. It is showing the direction, it means giving the example or example of information of these sentences. Yes, convection. Convection example of they are not contact each other any materials, but they are connected to one container and container transferring the heat. For example, one container and one heat, but inside the water they are not connected directly in the heat, but it is changing the temperature without connect any heat. Convection questions. Why does hot air rise and cold air sink? If you remember previously 2 page, it is giving the answer. But think. Answer is cool air is more dense than warm air. So the cool air falls through the warm air. Convection, it is giving the example in the daily life examples. Sun, they are sending the heat, and this heat, when they connected on the ground or on water place, they are changing the temperature. When they changing the temperature, it will be transferring the heat. As the air gets warmer, it becomes less dense and rises. Rises is meaning up. The cooler, more dense air above it is sink to replace it. It will then get heated by land. Questions. Why is the windy at the seaside? Why is it windy at the seaside? The land is warmer than sea. This land warm, the air above it rises. And the cold air from the above, the sea moves into take the place of warm air that has rising. If you remember, we said hot air, it will be rise. Or every time heat transfer from hot place to cold place. A Sebrys convection cycle. Look at this. Low air, it will be moving from sky to sea levels. When they are moving the sky to sea levels, air compressing. It's meaning it will be increase the temperatures. And it will be moving the higher to low because of it will be moving to higher temperature, low temperature, then air expand. When the air expands, it will be moving from low to higher sea breeze side. Heat convections. For example, in your home and in the freezing part. For example, convection current, when somebody they are preparing some insulator part, the outside of the building, but inside they are building the convection current. Every time inside the room, it is some constant temperature. And also freezing, the downside, generally it will be cold, and outside it will be hot. Convection, heat transfer in a fluid occurs mostly by convections. Buoyancy causes the warm air to rise, which carries thermal energy directly by its motion. For example, warm air, it is rising, or hot air, it is rising, and rising air, it will be moving the downside when it will be cool air. Convection oven has a fan to change the circulation of the air, increasing the transfer of heat. Convection in gases. Throughout the process of convection, the air surrounding your body warms up, rising and carrying the heat away. For example, in the warm area, it is moving in the bodies, cold and things. Where it the freezer compartment put in the fridge, it is put at the top because of cool air sink, so it cools the food on the way down. Freezing compartment, it is warmer at the bottom, so this warmer air rising and a convection current is set up. The third method of the heat transfer, radiation. Radiation in which heat is transferred by electromagnetic waves. For example, in the sun, when radiation falls on an object, it is partly reflected, partly transmitted, and partly absorbed. Absorb, reflect, and transmitted. Absorbed heat causes the molecules of the object to vibrate more, and so the object becomes hot. The temperature it will be increased. The sun sending the light to earth is called what? Answer is, there are no particles between the sun and the earth, so it cannot travel by conduction or convection. It's called radiation. Look at this. They are not connected and they don't have the particles. It's called radiation. The solar oven. Let me show. Avoid sand beach is poor absorbed and the poor emitted of radiation. What is meaning the emitted? What is meaning observe? Check and you will find the answer. Observe, when we are sending the heat, they are taking inside the objects. It's called observing. For example, if you remember about the biology lessons, why mostly leaf color is green? Do you remember? I think yes. Because of sun sending the all colors, but leaf absorbing some color and some color is reflect. If the reflected color, the green, you will see green. But if you observing another colors, you will not see these colors. Do you remember? I think yes. What about the emitter? Do you have an idea? No idea? Why? Emitter is meaning the electrode in transistor where electron originate or look like sand. For example, when you are sitting in the seaside on the beach, and the color it is important about the absorbing and emitter. A black root surface is a good observer because of it is taking all colors and good emitter of radiation. They are not reflect mostly. When they are taking the heat, it will be increase the more temperatures. Yes, the example of good emitter and bad emitter. Some surface emit radiation or emit radiation. Some surface emit radiation better than others. For example, bright shine surface are bad emitter because of it is reflect. Dull black surface are good emitter because of not reflect mostly, which I radiate away much of their energy. Shiny surface are bad observed. They are not taking, they are reflect directly and reflect the sun rays. Carefully, bright shine, bad emitter, but dull black is good emitter. And shiny surface are bad observing but good reflect. In electrical fire, a shine metal mirror is used for the opposite reason, to reflect rays out of the room. Yes, why do we wear black or dark clothes in the winter? Or opposite meanings, why bright clothes in the summer? You know, in the winter, the weather is cold. When we are wearing the dark color clothes, the sun sending the light, it is absorbed. It is taking the sunlight inside. They are not reflect. When they are not reflect, the body it will be warm. But opposite meaning, in the summer we are wearing the bright clothes It will be reflect. You know, in the summer weather is very hot. When we are wearing the dark color cloth, it will be observe the sunlight, the body temperature will be hot. Yes, black body. Example of a material that is good observer, like lamp black. Look at this. Is also a good emitter, and a material that is poor observing, like polished, the bright surface, like polished silver is also poor emitter. We can think poor emitter, it is good reflector, but good emitter is bad reflector. For example, absorption and emission. Solar radiation is the selectively absorbed by Earth's surface cover. Darker objects absorb the short wave and emit long wave. About the sun rays with the higher efficiency. In a forest, this is long wave energy melts snow. A solar cooker, example, when you are putting the one glass of water or tea, when you are putting the solar cooker, it means space is brightness, it is reflector, good reflector. It will be, the temperature is higher. And about the solar, look like solar energy systems, they are using the decrease the water, or look at this, glass covered the collector. They are using the sun energy and affecting the temperature of the water. And also the videos how we can using this solar energy and glass covered collectors. Questions about the radiation. Why are house painting white in hot countries? Think, for example, in the Iraq, in the Basra, it is very hot. Generally, house, the color is not dark. Why? Another question, why are shiny foil blankets wrapped around the marathon runner at the end of the race? Think. You have the 10 seconds. 5, 4, 3, 2, and time is over. Answer it. Did you find? Of course. Answer is white reflects heat radiation and keeps the house cooler. Another answer, the shiny metal reflects the heat radiation from the runner back in. This stops the runner getting cold. Example of the emission experiment. Look at this. We have the 4 different kind of material. One of them is shiny metal, one of them is dull metal, one of them is dull black, and shiny black materials. Yes, 4 containers were filled with the warm water. They are all of them is same amount of the water. Which container would have the warmest water after 10 minutes? You can try at home, small experiment, and you can give the answer. Questions? The blah blah. Container will be the warmest after 10 minutes because its shiny surface reflects heat. What's the meanings? Back into the container, so less is lost. What's the meaning? Container will be the coolest because it is the best at. And answer, heat radiation. You have 5 seconds. 5, 4, 3, 2, and time is over. Answer, firstly, the shiny metal container will be the warmest after 10 minutes because its shiny surface reflects heat radiation back into the container, so less is lost. The dull black container will be the coolest because it is the best at emitted heat radiation. And another example, observations, experiment. Also we have same for kind of metal and same amount of water, but for containers were the place from a heater, which container would have the warmest water after 10 minutes? Questions? The answer, container would be the warmest after 10 minutes because its surface absorbs heat. What's the answer? The best. And which kind of container would be the coolest because it is porous at which kind of container? Heat radiation. We have also 5 seconds. 5, 4, 3, 2, and time is over. Answer. The dull black container will be the warmest after 10 minutes because it is surface absorb heat radiation the best. The shiny metal container will be the coolest because it is the poorest at absorbing heat radiation. Vacuum flex. Vacuum flex, the thermos bottle minimized heat transfer by convection, and radiation. A vacuum or thermos flex keeps hot liquids hot or cold liquids cold. A vacuum flex is a double-walled glass bottle with a vacuum battery between the walls. Look at it, inside the vacuum flex look like one place inside the container and second place it is connected outside. Thermos bottles silver surface reflect radiation heat, vacuum prevents convection and conductions, insulators stop reducing conductions. Firstly, inside the vacuum flex it is shiny metal, and when they closing the tap off, inside the temperature and heat it will be reflect, but it is not moving out of the container. But surrounded the vacuum flex, it is insulator. Controlling heat transfer, thermos bottle eliminated conductions and convection by having a double-walled side with a vacuum. Cellular interior walls minimize heat transfer by radiations. It is example of three kind of transfer the heat. Home heating system. Heating system include the steam, warm air, hot water, and solar heating system, which depend upon convection current to distribute heat. Example of hot water heating system and example of warm air heating system. For example, one figure of system, they are using the one different kind of machine, and it is affecting the air of homes, hot air and cold air. They are changing each other. So radiation electric systems. In radiation electric system, resistance wire carrying the current radiate heat throughout the room, and convection current distribute it. In radiant hot water systems, hot water pumped through the pipe. Look at this. It is systems. When they increase the hot water, it will be pumping. This side is pumping the hot water. When they inside the home, cooling the water, it will be returned back in the machine, and when it will be increase the water, and it will be pumping again. Hot water pumped through the pipe radiates from the floor throughout of the room. And solar heating system. We have the two kind of solar heating system: solar heating system and active solar heating system. Firstly, passive solar heating system use glass and concrete in the structure of the house to collect and contain heat without an air distribution system. But active solar heating system use special solar collector to absorb the heat and send it to a collection area filled with the water or stones. Distribution of heat from the collection area is accomplished with forced air or water pumping. For example, water pumping and water tank. When they changing the temperature, it will be pumping inside the room. Example.
system, called a drainback system, can be used in any climate and requires no maintenance. Heat from the sun is collected by the solar panels mounted on the roof. The heat transfer fluid, usually water in a drainback system, is pushed by a circulation pump up to the collector, where it is heated as it moves upward through copper tubes in the collector. Once heated, the fluid exits the collector and circulates down to the drainback reservoir. The drainback system is an indirect system, meaning that the fluid circulating through the solar loop never comes into direct contact with usable household water. Heat is transferred to the main water line using a heat exchanger, and it is then stored in the tank and made available for use. An Eagle Sun system will allow you access to enough hot water to wash your dishes, do your laundry, and enjoy hot showers for free all year long. To calculate your own personal savings, click the Solar Savings Estimator link located on any page.
Yes, active solar heating system. Active heating system use solar collector on the roof of the building. Pipes run throughout the home and water is pumped over the hot solar collector, distributing heat to the rooms of house. For example, some example of active solar system heating and heat collector. Solar panel of an active system are placed around the exterior of the house, and solar panel look like this heat water that is pumped through the home. They have inside the solar system, they have some pipes, and surface of the pipe they have the 2 or 3 sheet of glass. And some example for active solar systems. And how does solar water heating work? The energy of the sun is captured by solar collector on the roof. Fluid inside the collector absorbs the heat and is circulated through the system. And passive solar heating systems. Passive solar heating system doesn't require too much special equipment such as pipes or pumps. A sun space is built on the south side of the building. It has a glazing material or a kind of glass outside, and the massive material inside they absorb and store sun heat. Example of passive solar heating system. And lastly, summarize passive solar system. 2 types of solar heating system, passive and active, are available in passive solar heating system. Solar energy heats room inside the building, but no mechanical device are used to move heat from one area to another. Just as in a greenhouse, materials such as the water or concrete inside a building absorb radiant energy from the sun during the day and heat up. At night, when the building being to cool, the thermal energy absorbed by these materials helps keep the room warm. Look at this figure and how our homes heat and cooled using the solar system panel or a kind of water pumping system. And another kind of, and our video is finished.